Okay, good morning, Professor David J. De Los Reyes. Okay, this is a long video format topic. It's college algebra, and this is now lesson number 11. Okay, let's proceed with lesson number 11. So, for those of you who are to take up SAT or CAT exam, this is for you guys. Okay. The subject matter for this morning will be college algebra, lesson number 11. We are running smooth. We have finished the fundamental operations, what do you call this, the correct procedure on how to evaluate expressions. So we will now proceed with the solution of the subject matter for this morning will be linear equations involving one variable. It will be the solution of linear equations involving one variable. Linear means it's a straight line. So meaning the solution is just only one. But under the study of what you call this college algebra, there are three types of solution. I will try to bring out first the three types of solution, but we will concentrate on the most relevant type of solution, that is the conditional solution. Okay, before I will proceed with this, I will try to discuss first what is an equation. An equation will be something like a 5x minus 2 and they should be equal to 0. For it to be considered an equation, there should be an equality sign. There should be an equality sign. Because without the equality sign, okay, that term is not an equation. It will just be simply an algebraic expression. But if there is an equality sign, equal sign, and this should be equal to A. This is just for an example or an illustration. What will come out will be the term so-called equation. Okay. Let's try to bring out the form of a linear equation. Linear equation will be of the form capital EX plus B equal to C, where the values A, B, C are all real numbers. Okay. The condition should be that A, B, C are all real numbers and C is not equal to 0. So the equation for it to be linear, the form will be something like this. And if you try to graph the equation of this, it will be something like this, a straight line. Okay? So for a straight line, there will only be one solution that is under the so-called conditional type of linear equation. That is, the resulting solution will just be only one. It is only one. For this example here is x is equal to 2. That is just an illustration. So for it to be considered a conditional linear equation, the solution should only be one. No other thing. Okay? Okay, before we will proceed with the example problems on how to solve the linear equation, okay, I will try to bring out what they call this, what is the solution of a linear equation? A variable that makes the equation true. So for this x here, if we put x here and we try to simplify both the left and right, what will come out will be a true thing. So for it to be considered a solution, when we will substitute that x in the linear equation, what will come out will be a true condition. It should be a true condition. It will not be a false condition. It will be a true condition. It will make the equality, meaning equal for both the left and right. It's an equal thing, right? Okay, let's try to bring out the needed properties and how to solve linear equations. These are just concepts, okay? Don't be bored. The concepts needed in the solution of linear equations are actually, there are 5. If A is equal to B, okay, we can say that A plus C will be equal to B plus C. A is equal to B, so this is actually the additive property. Whatever you add on the left hand side and you add it also on the right hand side will not change the value of the equality. Okay, so this is the so-called additive property. That is, if A is equal to B, if we add C on the left hand side and we add C also on the right hand side, we will not change the value of the equation. That's the first one. This is the so-called additive property. The multiplicative property is something like this. If A is equal to B, A times C will be equal to B times C. Okay? If you multiply the left hand side by C, and you multiply also the right hand side by C, you will not change the value of the equality. That is the so-called multiplicative property. Okay? The third one, it follows that under the addition and multiplication, it follows also under the subtraction. If A is equal to B, A minus C should be equal to B minus C. You subtract minus C on the left hand side and you subtract minus C on the right hand side, you will not change the value of the equality. Okay? That is the so-called subtractive property. The last one, the second to the last. If A is equal to B, it can be written as A over C, and this should be equal to B over C. The meaning of this, if you divide the left hand side by C, and you divide the right hand side by C, you will not change the value of the equality. Okay? That is the so-called division property. The last one, it will be the so-called distributive property. This is one of the, properties of fundamental operations. We will always be using this property here, that is the product of A times quantity B plus C. It can be written as the product AB plus AC. We always use this. So I specify this as number 5. So with this 4 here, plus the distributive property, I think we are now ready on how to solve the solution of a linear equation in one unknown. Okay, there's a quotient on the solution of linear equations. It's not only linear equations. As long as we are solving equations under college algebra, we should follow this one. The equality sign should be vertically downward. Okay? It will be something like this. Vertically downward. We write it in columns. I place it here vertically downward. They are aligned in columns. Vertically downward. Equal sign, equal sign, equal sign, equal sign. So it looks neat, right? And only one equality sign in a horizontal line of work. Meaning, this is one horizontal line of work. The meaning of this, there should only be one equality sign. Okay? Just stick to that one. So your solution will be as neat as possible as it can be here, right? Okay, we now through with the quotient on how to solve linear equations or any problem under college algebra for that matter. Let's try to bring out the 3 types of linear equations. We will only be concentrating on the conditional because this is the one we need in real life, the conditional type of linear equations. But I will try to bring out also the other 2, that is the identity linear equation and the contradiction linear equation. Under the conditional type of linear equation, the number of solutions will only be 1. Only 1. And the indication will be something like this. If x is equal to 2, x will be equal to 2. If x is equal to -1, x will be equal to -1. No other value. So under the conditional type of linear equation, the solution should only be 1. And in real life, we will be only concentrating on that type of linear equations. The next type of linear equation is actually the identity linear equation. For the number of solutions for identity linear equations, there are infinite real numbers. There are so many as long it is real. The condition is that the number should be real. Okay? The indication will be something like this. It will be 0 is equal to 0, or a negative 1 will be equal to negative 1. So the meaning of this, what comes out on the left should be equal to the one on the right for it to be so-called identity linear equation. For the last one, it is the contradiction or contradictional linear equation. Okay, and the number of solution, none. There is no solution of this. Okay, because what will come out in the equation will be an indication something like this. A negative 5 is equal to negative 6. It's not actually not equal. Right? Meaning the value of the left hand side is not equal to the right hand side. So under the contradiction, instead of this one to be equal, it is not equal. Okay? For the first one, there is only one solution, x is equal to 2. Only one solution. For the next one, there is still an equal sign, but the value for both the left and right is actually the same. That's why it is called identity linear equation. But for the contradiction linear equation, since there is no solution, the value of the left hand side is not equal to the right hand side. Okay? But mostly, the problems we will be solving under real life conditions is actually the conditional type of linear equation. Okay guys, those are just concepts, and I think we are now ready on how to solve or identify what type of solution that will be coming out for our next two examples. Okay, I will give you example number 1. Example number 1, the given equation, it is not expression anymore. It is an equation because there is an equality sign, right? The given equation is minus 3x plus 6 minus 5 times the quantity x minus 1 close quantity equal to negative 5x minus 2 times the quantity x minus 4 close quantity plus 5. There's an equal sign over here, so we are given an equation. Okay, how do we know if it is linear? The power of x are just all 1. X is just simply same as x to the first, but under algebra, if we do not put the power to be 1, it is understood to be unity. So, for the given example number 1, it involves a linear equation. The power is just simply 1, okay? This is x, this x, x, so they are all linear, okay? Okay, let's try to bring out the solution. The requirement of the problem is solve the equation and identify what type of linear equation that comes out. Is it conditional, identity, or contradiction? Okay. If we try to bring out the solution, okay. That's why one of my topics under my short videos is simplification. Okay. Proceed with the simplification as long as you know the fundamental operations. The sequence of operations, you know it, right? And you know what's the definition of a linear equation, what's the definition of a solution, okay? We cannot proceed with the solution. So if we are given this equation here to bring out the solution, just simplify, okay? Okay, let's try to bring out the simplification. Maybe in the simplifications, we will be using these 4 properties here, including the distributive property. Okay? For the first one, minus 3x, we will not do anything. We write it as it is. Okay? Plus 6. For this portion here, we got the operation multiplication, right? So we will be using the distributive property of fundamental operations. So we expand, we distribute, right? So a negative 5 times a positive x will be negative 5x. A negative and a positive will be negative, and this will be negative 5x. and a negative 5 times a negative 1, a negative times a negative will be positive. Okay, that is by placing the proper sign under the fundamental operations. So a negative times a negative will be positive, and 5 times 1 will be 5. So this will become plus 5. What did we use over here? It is the so-called distributive law. Okay? I am telling you this one that we use distributive law because I am teaching. But if you are solving, okay, just continue solving, right? It is understood that you use distributive law. For the right hand side, okay, I write the equality sign, okay, in column, vertically downward. I follow this one. So it looks neat, right? Negative 5x, I didn't change any value. This one here, we got again a quantity here and the operation is multiplication. So again, we will use this distributive law. A minus 2 times a positive x will be negative 2x. And a negative 2 times a negative 4. A negative will be plus. Okay? And a 2 times 4 will be 8. Plus 5. Okay? Then try to simplify again. What will be the next simplification? Oh, it will just be simply what you call this collecting similar terms for both the left and right. The similar terms on the left hand side are the terms with the x variable, right? So I write this as one, you could write this as one quantity. You don't have to place the quantity, just write it beneath, what you call this, beside each other. So negative 3x minus 5x plus 6 plus 5. Actually, you can place the quantity if you want. Anyway, the operation is addition, right? So this is the same as just like we are, what they call this, change the grouping, or we do some grouping, right? It is the so-called associative law, right? So this should be equal to, the equality sign still goes in column vertically downward. And again, on the right hand side, we combine the terms with similar terms. I just rewrite negative 5x minus 2x. You can place a quantity if you want. The operation is addition. And the pure constant term is 85. Again, you can place a quantity. It doesn't matter. Okay? A negative 3x in minus 5x, you're adding similar terms. Luckily, their sign are both negative, so they will add up, right? So negative 3x minus 5x will be minus 8x. And a 6 plus 5, they are both positive and you're adding it, so it will be the sum. That will be plus 11 equal to the right hand side. Again, you are adding two negative terms, right? Negative 5, negative 2 will be negative 7x. And you're adding both positive numbers, and 8 plus 5 will be 13, so this should be plus. Okay? So the meaning of that simplification is that you combine similar terms for both the left and right. Okay? Then according to the solution of linear equation, try to isolate the terms with the unknown variable. So I will maintain negative 8x. Okay, I will transpose this negative 7x to the left, so it will now be plus 7x. Okay, I will maintain 13 on the right hand side, right? But I will transpose this 11 to the right hand side, so this will now be minus 11. So actually, by the so-called process of transposition, I isolate the terms on the left hand side. So a negative 8x plus 7x, they are both similar, right? A minus 8 plus 7 is a minus 1 multiplied by x. And this should be equal to 13 minus 11. A minus x equal to a positive 2. We are solving for x, right? This is negative x, and we are solving for x. So to solve for x, okay, we will multiply both the left and right by negative 1. So negative x times negative 1 equal to 2 times negative 1. Why I did this one? I use the so-called property number 2. Okay? That if you try to multiply the left hand side by a certain number, you should also multiply the right hand side by the same number, and you do not change the value of the quality. So actually, minus x times minus 1 should be equal to 2 times minus 1. A negative x times a negative 1 will be negative will be positive x, and a 2 times a negative 1 will be equal to negative 2. So our answer is actually negative 2, the solution. And this falls under the conditional. Okay, conditional. Only one solution, x equal to 2. Okay, for this, it will now be equal to negative 2. This one. Only one solution, and that type of linear equation is actually a conditional linear equation. Those are the real life problems we will be encountering, okay? Okay, last example for this morning. 7 multiplied by, open bracket, 2 minus, open quantity, 3 plus 4x, close quantity, close bracket, minus 2x, equal to negative 9 plus 2 times the quantity 1 minus 15x, close quantity. There is an equality sign over here, right? So this is not just simply an expression, it is an equation. There is an equality sign. Okay, the requirement of the problem is solve for the value of x and identify what type of linear equation that will be coming out. Okay, let's try to bring out the solution. 7, open bracket, okay. We start with the mode of operation, right? We start with the terms inside the parentheses first, right? But inside the parentheses, okay, this two here, as it is, but for this one, we must have to eliminate the quantity here. This is preceded by negative sign. So under the so-called series of operation, we should distribute this one. It seems we are given a negative 1 over here. Negative 1. Negative 1. This plus. Okay? So a negative 1 times a positive 3 will be negative 3. And a negative 1 times a 4x will be negative 4x. Close bracket. Minus 2x, as it is. Equal to. The equality sign, it's vertically downward, right? In columns. Okay, so it looks neat. And this should be equal to negative 9, as it is. Plus, this one here, it seems we are given a plus, this is still a plus, and this is a plus 2, something like that. So a plus 2 times a plus, 1, positive 1, will be a positive 2, and a plus 2 times a negative 15x will be negative 30x, right? So we use the so-called distributive law over here. Okay? Let's try to continue simplification. For the left-hand side, we must have to simplify first b1 inside the bracket. So 7 times open quantity. A 2 minus 3 will be negative 1 minus 14x close quantity minus 2x equal to, okay, vertically downward. Okay, minus 9 plus 2 will be minus 7 minus 30x. Okay, we perform again this operation here. What operation is that one? Again, it is distributive law. We distribute. So a 7 times negative 1 will be negative 7. And a 7 minus 4 will be negative 28 times x. Okay, minus 2x equal to minus 7 minus 30x. The equality sign is still in column, vertically downward. Okay? A minus 7, then for both the left and right, try to combine similar terms. Okay? Minus 7 as it is, minus 28 minus 2 with the variable x should be negative 30x. And this should be equal to negative 7 minus 30x. Okay? Then try to isolate the terms with the unknown, right? So we will maintain this negative 30x. Okay, we will transpose this one to the left, so it will now become plus. We will maintain this negative 7, then we will transpose this negative 7 to the right, so it will now become plus 7. And negative 30x plus 30x is 0. Negative 7 plus 7 is 0. What comes out is actually an identity. And the solution is actually of infinite solution. Why infinite? Because on this equation here, if you put x to be equal to 0, it will satisfy the equation 0 is equal to 0. If x is equal to 1, again, it will satisfy the equations as, what you call this, 0 is equal to 0. Right? So the solution of this is, the type of equation of this one is actually identity linear equation, and the solution is infinite, all infinite real numbers. There are infinite values which will satisfy this equation here. Okay, that's it, guys. That's the solution of a linear equation. Okay, so for those of you who are taking up college algebra, this is for you guys. This is now the proper way on how to solve a linear equation in one unknown. At least we now know what is an equation, what is a linear equation, what is a solution of a linear equation, what are the needed properties to bring out in the solution of a linear equation, what is the quotient that should be used in solving a linear equation, and what types of linear equations that is involved under linear equations. There are three: conditional, identity, and contradiction. Okay, so if you would like to subscribe to my channel is at youtube.com/@proofdavidjdelos. If you want to share it, please click share. Okay, this is for you guys. The subject matter involved concepts and example problems. Okay, good morning from Los Angeles.